right? If you can imagine, we have not even been in Java 2 weeks yet. This is only class 4. So I'm going to go over chapter 5. The good news is a lot of the basic stuff we've already kind of touched upon. So now it's going to be the more in-depth understanding of it. I'll try to go over some examples. In my opinion, the examples and some of the other stuff that they gave for this chapter, I don't think really got you to the depth that you probably needed or followed along with the book as well as I hoped. Either that or I just didn't read the examples correct. So we'll go over them, but definitely ask some questions. I will allow a little bit of time for graded assignment questions, but to be honest, with graded assignment, I told you the first thing to do is to get that print function working, and that's what you really need to do. The rest of it, I'm going to show you tips and tricks on Monday, because that'll give you a full week to get those done. But graded assignment 1 might take people some time, but it's not a lot of code. It's like 20 lines of code and that's it. But it's knowing where and the syntax and really what's going on and reading the code that's already there, because there is a lot of code already. So it's not the code writing as much as the understanding, which to be honest is more like real world. I'm going to try to do a studio intro. I will help, but I did not get what I wanted to done for that before class. So there's this thing, more vocabulary to throw at you, that final field, it's kind of like the const. So final and const are almost pretty identical. And then the only difference is, actually, I think JavaScript does the same thing. If you have a const that's a primitive, a const that's like an int, once you set it, you can't change it again. So that is the same in both. And I actually think it's the same in objects, meaning once you assign an object to a final field or a const, you cannot change like the wrapper of the object, meaning like the memory location of the object, but you can manipulate the stuff inside the object. So I'll show you a little bit about that, but I think that's the same in both JavaScript and Java. We have talked about static before. Remember, static means that you do not have to create an object or create an instance of an object to use that field, or if it was a static method, to use that method. So static means that you don't have to instantiate or create something. You can just use it. Constant, so that's just the same vocabulary. Constant JavaScript is the same thing as like a static final, where you can just use it anywhere. You don't have to create an object. You can just use it. Instance methods versus static or class methods. That's the same kind of thing. Like if I create a person and that person has a name, that's like a class field. But if, let's say, methods, again, this is where my brain is not all the way on there. I was trying to come up with an example right off the top of my head, but so methods are usually actions. So let's say that you wanted to print a name, then a static method that wouldn't be as good because it would just print whatever you put into it. Like you didn't actually create an object to it. So that's why it's not a very good example. But there are certain cases, like with math, all of your math methods are static because you don't have to create a math object to then call your methods. You just do capital M, which is the class, not the instance of a thing, capital math dot whatever, and then you can call those methods without creating an instance of it. Same thing, accessing static and instance fields, how to get those. So, and then I will spend a lot of time on the toString and the dot equals today. And then it does remind you about the setters and getters and all that generated code. In IntelliJ, you just right click, hit generate, and you can do constructors, you can do setters and getters, you can do your toString, you can do your equals, all of that stuff. IntelliJ just kind of, those are done all the time. So they just put shortcuts in there. I wanted to go. There was 2 questions. I think a third one got asked towards the end, but hopefully I addressed that one whenever I'm actually going over the live coding. So the first thing was, why do you overload and not name the methods like something different? And I was trying to come up with a good example of this. And the person that asked this was like, I kind of understand it with overloading constructors, meaning if I have a person, sometimes I know their first and last name, but maybe I don't know their age yet. So I can have a constructor of first name, last name, and then I can have a constructor of first name, last name, and age, and then I can, create it either way. So why do you, whenever you're doing methods, why would you need different parameters to be put in? And I will task myself to actually come up with an actual example of this before Monday, because I think it's such a great question. I think an example would kind of solidify it a lot more. But the process of overloading methods are exactly the same. Yeah, I just can't tell you a good example right now, but oftentimes you'll want methods, and then whenever you scale things, sometimes you'll write methods and you'll have like a default, like these are the 3 things, but now you have 4 things, so you've added an additional thing that you want to pass in, but because the other ones still work, you just add this other thing in, and then what that does is it kind of calls the other one. So you start like chaining these things, not chaining, it is overloading. You call one and then it calls the other one and it throws in the extra parameters in there. And again, with a good example, it's not going to solidify for you. I'm going to try to think about this one even today, but I will definitely, I promise I've actually already written it down on my to-do list of coming up with a good overloading methods for you for Monday. The second one I can answer with strings. Why does the 2 equals work? Sometimes, most of the time, for you guys, they'll work most of the time, but they're objects. So we were told that we should use like the dot equals every single time. So I do want to confirm information, and then I will answer that one more directly. So what you guys are talking about, this comes from the book. If I do student 1 and student 2, and if I did a asking of equals on this first one, it would say false, because the location, the circle of the student versus the circle of this student is different. Even though the names are different, even though the whatevers are different, when you do a double equal sign, it checks, are they pointing to the same location? And so these are not pointing to the same location. So this, if you did an equal, not a dot equals, but an equal, this would return false. This one would return true. So that's just a visualization of it pointing to the same place. So a comparison operator, a double equals, looks to see, is it in the same memory location? Okay. What happens with strings, and this is Java specific, your JVM, your Java virtual machine, when you're dealing with strings, so if I was talking about strings and not students here, it wants to be as fast as possible. So whenever I say, let this string equal Philip, and then I say, hey, is that string double equals Philip? It's going to say true. But you're like, well, that's not in the same memory location, right? But the JVM, whenever it compiles, it actually takes all of your strings, because it knows that strings are special like that. It takes all of your strings and it sees if there are duplicates or whatever else, it puts us in this registry and it actually points them to the same spot. So strings are unique in that case, where strings do point to the same memory location. And I'll show you how you can actually work around that in the live coding section. But if you research, what's the name of it? I wrote it down somewhere. String constant pool, that's what it is. There's a string constant pool, a constant pool of strings that are just constant values, because remember, strings can't change. So all it's doing is it's reallocating those memory locations. So hopefully that makes a little bit of sense. I'm going to show you some live coding things about that here in a second. I'm going to try to answer some questions. So a question was, why do we need more than one constructor if it only gets stopped for the lowest requirement? Will be notified if they don't have an age. All of this is how you program it. So meaning if in your UI, you have a form and you're asking for first name, last name, and age, you can set form validations to say you have to have an age. So those are validations on input. Whenever you're just doing like line code, like what we're doing, like inline code, you can create a person with just first name, last name, or an age. But if you set up a constructor for just first name, last name, unlike JavaScript, I don't know if you remember in JavaScript, you would just set all the parameters, and it had to be in order. So the first parameter had to match, the second parameter had to match. But let's say in JavaScript, you had 4 parameters in your constructor. If you didn't use the last 2, you just didn't have to throw anything in there. And JavaScript was like, yeah, sure, you don't need to throw that in there. But with Java, it's so strict that if you have 2 parameters, you have to have 2 parameters whenever you create the object. If you throw in a third, it's going to throw an error. It'll also look at the types of those as well, such as if I set up a person and I say first name, that means string and string. But if I threw in and tried to create a person with their first name and age, it wouldn't do that unless I had a constructor that showed them how to do that. So with Java, you have to explicitly say exactly how you want it to set up, or else it'll throw errors. I do want to spend a little bit of time on this equals. Hopefully this is the only time I really need to, but because in the real world, I rarely do the equals. To be honest, in the real world, I rarely do the strings because Java is meant to be a backend language, like an API, and we're just sending and receiving data. So I'm not checking to see if something is equal very often. And if I'm trying to see if something's equal, I'm actually, instead of calling an equals on a class, I'm just going to call it on the name or the ID or the whatever else. I'm just going to look for does this thing dot ID equal this thing dot ID, not does this thing equal this thing. So it is good to know about these things. It's good to practice these things, but if it's something that you're thinking that you need to remember long term, don't worry about it. So these are the 5 things that they suggest whenever you're doing an equals, and I will go over this in the live coding as well. The first thing you want to do is to check reference, meaning where's their memory location at. If they're located, if it's pointing to the same memory location, the same reference, then you know they're equal. They have to be. So go ahead and return true, and you don't even have to go through all this other mess. But if they're not equal, then we want to make sure that the things that we're dealing with are not null. Because if one of them is null and it's empty, then obviously it can't be equal to anything. So let's go ahead and return false on that one. The class check, and this goes into another question somebody asked, was like the get class. What does that really do? Well, I could say person dot equals parentheses and then put a course in there. Well, a person and a course are not the same class type. So what it'll do is on number 3, it'll say, hey, is this even the right class? If it's not, then I know they can't be equal because a person cannot equal a course. So it'll return false. And then once I know that they're the same object type, the same class type, then I'm going to actually cast the thing coming in, because whenever I grabbed it originally, I grabbed it as an object, and an object can be anything. So once I know that it is a person, then I'm going to say, hey, treat this like a person. Don't treat it like any object. Treat it exactly like a person, which ensures that I get all the field values and the methods now on that person, because every person has to have those fields and methods. And so I'm going to cast it to be the right type. And then this custom comparison is just however you want to compare it. If it's a person, if they have the first, do they have to have the same first name and last name, and then they're the same person? Do they have to have the same first name, last name, age? Like what are all the qualities? That's why it's a custom comparison. What are all the qualities you feel they need to have to be considered the same person? These I am not going to go over. I'm just showing them because the book had them. But this is a lot of, most of these are like more mathematical, logical, proof-based. So when I was doing my upper level math, I had to do proof-based things like making sure things that were transitive property, were they symmetrical, were they reflexive, like I've actually, done a lot of math with these things. So I threw them out there because anybody else out there that, is a nerd with math will know some of these words. But really all this is doing is checking all of these, because if we want to say that it's equals, these are the properties that have to be satisfied. Well, how do we satisfy most of them? Most of them are satisfied by these 5 checks here that we will go over. So like this is the practice of the theory of the stuff that they've been doing. So just know that, yeah. Again, do your stuff. Graded assignment is due in about 11 days. There we go. Again, I'm going to already apologize because my stuff is not as good as I want it to be. Right. First thing I'm going to do is go over, these are the things that they have. I had to comment all of this stuff out, but I wanted to go over this first. This is what they were talking with final fields. So I just want to make sure you guys understood. Final means it cannot be changed. When you have a final that is not assigned at the beginning, you can assign it later. And then it won't change. So what I like about IntelliJ, the reason why I'm not going to spend a lot of time, it actually tells you there's going to be some kind of error. You need to add something here. You need to initialize this. The only thing I really do want to point out, once you actually assign an object, because this is a new 42 object, if you try to assign it to another one, it's an error. But if you actually want to change the value inside of it, that's fine. So you're not changing the memory location, you're just changing the values inside that memory location. So that's why this is able to do. So hopefully you guys read through a lot of that. I didn't see any questions on that. Constants. The cool thing here, this is constants. It's also static. That means that I can do this without declaring something. So I am going to show. Let's do this. Let's create a new Java class. I'm just going to call it fun. I'm going to do the public static void main. Right now, if I wanted to call the first president, this is what I want to do. I want to call the first president in my fun class. Hopefully you guys can, you guys will start seeing into my world because this is how I view things all the time. So if I wanted to print out George Washington here, what I would do, since it's a static, I would say constants dot first president. And do you see how constants is a capital C? And this should work. If I hit run here, it actually printed out George Washington. If it's not static, then I cannot do this. What I have to do is I have to say, hey, go make a constants object. I can call it whatever I want to. I'm just going to call it C just so that you don't even get confused on the naming. And then I would say new constants. And then to call this, I would do C. So that's that I created an object and I called the first president of that object. So that's the difference between static and not static, is you had to create a new constant and then call it this way. So hopefully that just another explanation of static. And then final just means that we can't change it. So if I go over here and do constants dot first president equals something, it's not going to like it. It's going to say, do I want to make this not final so that I can actually reset it? So since it's final, I cannot reset it. Hopefully that was pretty straightforward as well. Oh. Okay. 42 is just that object of 42. That's not a big deal. And then temperature. This is where they start throwing new exceptions. I don't know if we really used this very much. So I'm not going to keep going on that. Close all this. In the exercises, I don't remember too much on the exercises. I don't think they actually made you do much with it, but I just wanted to go through these. If you have a teacher, I think this was already set up for me. This is a traditional class here. It's teacher. I have these fields. I have a constructor that sets up all of these. I have all of my setters and then all of my getters. And again, the order does not matter. I do think that either you want all of your setters together and then all of your getters, which is one way, which is absolutely perfect. Or I think what I see more often is the setters and the getters of each variable type or each field together. So either way works, but that's already set up for you. With the student, they have this main down here, which I really don't like. I don't like having main classes in object classes. And I think I just followed the book. The book said, hey, make the grade level this. It's static so that you can do it on any student. It doesn't matter about the specific student. The add grade, I did my mathematics different. I don't know if you guys are one of these ones that like single lines versus 4 lines, but I did all of the GPA calculation in 1 line. This is not a math class, so I'm not going to go over that. Your main or runner class should be its own class every single time. So what I should have done, what this should have been, students are students. Students are not running the program. So it's one of those where I would just create a new, I can call it main, I can call it runner, I can call it whatever I want to as long as people know what it means. And then I'm going to run this stuff inside here. So anything, a student should be a blueprint for all students. And that's, in Java, you're supposed to have more files. Just know that. The more files you have in Java, the better your coding is. So I think the rest of these are the setters and getters. The only other thing I did was this equals. So I wanted to go over this, and I'm going to go over an equals again here in a second. But what's going on here, to be compared is the object that's coming in. You get to name this whatever you want to, but the to be compared, first thing it's doing is to be compared is the thing that you're trying to do. So before this, let's figure out what syntax. What it's saying is like, hey, if I made a student one, so let's say that student one was a student, then I would do dot equals, and then I would say student two. Now this is all red because I didn't actually I haven't made student one and student two here. That's why they're red, not because syntax is wrong, but just know that this is what's trying to call this. So whenever I say this keyword here, I'm talking about student one, because the equals is on the student one. The equals belongs to student one. So anything I say with this is student one. The thing that I'm putting in the parameter is to be compared. So it's mapping this student two to the variable to be compared. So hopefully you guys understand this is whatever the equals is attached to. This to be compared is this thing, whatever I passed in. So it's saying, hey, if the to be compared, if student two memory location is exactly where the reference memory location of student one is, they have to be true, because there's no way you can point to the same spot and say that they're different. So just go ahead and take that one off the table. It's true. The next thing I want to know, student one cannot be totally empty because I'm calling equals on it. So I don't have to check that one to be null, but student two, I don't know anything about student two. And so I want to see, is student two even have something in it? Because remember, this can be any object type. I could have said course one here. I could have said whatever. It doesn't know. So right here, it's saying, did you even put anything in there? If you did not put something, if it's null, well, they can't be equal. So don't even look at that one. The next thing is the student two, you're going to get the class, which is the blueprint, not anything inside of it, but the blueprint is the structure of student two, the blueprint, the class, get the class of that. And if it's not the same as you could, and I've seen a lot of this in coding, you can do this dot get class if that helps you understand where this is coming from. But when I don't put the this dot get class, it assumes that it's this get class. So if I don't attach it to anything, it's assuming this one. And so I know because student one is student, this thing should say student. And it's going to say, well, is the class of student two student? And if it is, then you keep going. But if it's not, I'm going to say false. Meaning if I said course one here, are they the same? Nope. So it's going to keep going. Is course one null? Nope. So it's going to keep going. And then right here, it's going to say, oh, course is not the same thing as student. So I'm going to say they're not equal. On the other hand, if it is student, these are both students. But just because they're two students doesn't mean they're the same student. So I got to keep going. Have we talked about casting in here? I don't think we have, but did we talk about casting in JavaScript? No? Okay, so this could be a confusion point. I'm sorry that we didn't talk about this before. So line 75. Are we good on the left side is just saying, hey, I'm going to make a variable and it's going to have a student blueprint. It's going to have a student class. I'm going to name it the student. It doesn't matter what you name it, but that's my variable name. This is my type. So that's whatever. When I say equals, that's what am I actually going to hold in that memory location? Well, this thing right here says, whatever this is, change it to fit inside the student blueprint, the student class. That's what this thing does right here. It takes this object, the to be compared, and it says change that object, instead of it being a generic object, change it to a student object. So hopefully this at least makes sense now what we're doing. where we confirmed on this line. If you don't do line 71, you cannot do this one very well. Because if I had course here, and then I said, and I didn't have this one, right? If I deleted, I'm just going to delete it away. So it's no. I'm going to put it back here in a second. If I said course 1 and I did not check here, when it got and it tried to put course 1 right here, this would throw a huge error. It would throw an exception, and then it wouldn't let it would stop your program unless you did, the try catch. So remember, we have talked about try catch. So you could do that, but that's not what the purpose of the equals is. The equals is a yes or no. Are they equal or are they not equal? So I'm going to change all this stuff back. So you don't want an exception thrown here. So you actually check to see if it is the same class right here. So I know line 75 now is not going to throw an error because I know that the classes of both objects are the same. So now I can take this generic object and actually say, fit inside this thing of a student object. And then at the end, this is our custom. This is custom. I can make this be whatever I want to. This is suggesting that the student, that's the object to be compared. I can change this. Whatever you want to name this. To be compared student. I'm going to get the student ID of that. And remember, if I just call a method without an object, it's the same thing as saying this dot. So this means student 1. So student 1, student ID, student 2, student ID, are those the same? And you're returning yes or no, because remember, an operator like this is returning true or false. I could, in this same thing, I could put a huge thing around here and say, to be compared student dot get name has to be equal to get name. And I mean, I can do whatever I want to. I get to create this custom thing to say, do I think it is equal or not? You will be utilizing this in one of the graded assignments. I think it's the second one, but just know you will have to create your own equals, doing something almost identical to this. I always suggest just copying and pasting and then modifying how you need to. So don't think that you have to create every line of this on your own. No, you go to the book, you copy everything that they put in there, and then you modify it for your own. So I'm going to read some questions, and then I'll come back. I think I have one more thing I want to show you, and then I'm pretty much done. Yeah. So good question. When using the equals hash map generator, should there be something that we watch out for? I think that's a great question. To be honest, I never used that one. So I'm going to just go ahead and generate it real quick. It will say, okay, so this, not that you need to watch out for it, but the equals, it wants to know, these are the 4 fields that I could compare to each other, each object. Get the first name of object 1 and the first name of object 2 and compare them. Same thing with the last name. So this, you get to select which ones you want. And then LaunchCode doesn't go over hash code, and I don't think you guys should really worry about it as well. These are saying not null, meaning, are you requiring them to have these, or is it okay if it's null? So here's your equals here. again, going back to the original question, is there anything here that you should be like avoiding? I don't think so. I think this will do just fine. So yeah, you could probably use this. Here's if these things equal each other, you're going to return true. Remember, that's how we already did it before. Here it's including step 2 and 3 together. It's saying, hey, if it's null, return false, or if the classes don't equal each other, return false. So this is just doing steps 2 and 3 together. This is doing step 4, which is casting the object to an actual teacher object, because that's the class we're in, is a teacher object. I moved to the teacher object out of the student object here, the class. And then it's saying if, and it's doing all these if statements. And all of these are just checking each other. So it's the same idea. Here's your custom code. You can do this. That's fine. So I think I answered the exception thing as soon as it got asked, I think. Override line on 62. I don't know, did I delete something? If you asked about the override button, not button, annotation. I will answer generically. Every object that exists in Java automatically gets methods on it. So we said that this object to be compared, if we say object, this class object automatically has hash code on it. You know, it already has equals in it. So because every object that we ever deal with automatically gets, you know, pushed on the side of it, the equals, the toString, all of that stuff, because it already gets it. This annotation at override says that we are overriding the generic equals, and now you should use this one. I would love to do some research on this, because usually if you don't include this, it throws like a big red flag and says, hey, do you mean override? But it seems like in later versions, maybe they don't need this override. But that's what override is doing. Overriding is saying, don't use the generic equals, use this one. When we get into like parent classes and child classes, and like the child inherits all the parent classes, and so there might be methods up here that you want to like rewrite down here in a different class, you'll use the override to say, hey, don't worry about that one. Sometimes you'll use the at super to say, yes, use the one above. So there's different ways to, these are called annotations. That is the technical term. The annotations will help drive what the code is actually doing. So these annotations are important later, more later than right now. How do we know the items that we are comparing belong? Hopefully that one got answered. Is it this thing here? Yeah, it says, so this is telling you that it's overriding the method in the object. So it is telling you that. It's just warning you that even though you don't have any other methods in this class that's toString, because that's the other thing. If I said toString here, and then right underneath it or anywhere in this class, if I say toString, one of these is going to light up red, and it says, hey, it's already defined. You can't do this. But because the toString is defined in the object class, I may not know. I may not realize that there's two of them. And so this override says, hey, make sure you know that you're overriding this thing. Um, hopefully, keep asking the questions. The only other thing that I wanted to talk about before Studio, there has been a question / concern about array lists with hash maps and this kind of thing. There are many ways to do this. There's actually a way. If we have time, which we will, if we have time and I have the energy, I might show you how to do this backwards, where you have a hash map and then you have an array list on the inside. But let's say that we were talking about like just generic student info. This is not a good example, because what I would typically do is, instead of having an array of hash maps of student info, I would just have an array list of students. And then this would just be students. And then I would have student objects. That's the best way to handle this. On the other hand, I'm trying to help you with the graded assignment and potentially the Studio, depending on how you do it. So I'm just going to show you this. Let's say that for some weird reason, I wanted student info. Let's put the S at the end. Student infos. So the student info are the hash map, and then because it's a list, there's an S. So what I want to do is I need to generate this. So so the array list, student infos dot add, and then I need to have a hash map. Well, that means that I need to add the hash. I need to create the hash map first. So I'm going to say hash map string. And because I'm putting student infos in here, I'm going to say student one info. And because hash map is an object, anytime you're wanting to assign something to an object, you're going to say new object. Now, if I know exactly, like if I had a constructor, I would just throw the stuff into here, but I don't. So then what I'm going to do is I'm going to say student info and student one info, which is a hash map. I'm going to say dot. And to put something inside of a hash map, I think it's put. Yep. Let's do put. And then the string key. So let's say name. And let's say that this name is going to be Philip. Let's just do more info. No, those look so close to one another. There you go. What other info do I want to put in here? Now, here's a common thing. Because my hash map is a string, that means that both of them have to be strings. So even though I'd be tempted on putting an int in there, I'm actually going to put a string in there. Right. So I can put in whatever I want to into this hash map, but that's for student one. I'm going to go ahead and do student two. Actually, just to show you that because with the hash map, you don't even need to have every single property. You get to decide what properties go in it. You can do this. So now I have student info one that has these things that I put in it. Student info two that has these things. If I want to add these in, it doesn't matter the order really. I'm just trying to do this where I put all these things in there and then I added it to my array list. And then I'm going to add student 2 to my array list. So now student infos, the array list has 2 student infos in it. Could be whatever. It doesn't matter what these are. So I put it in there. Now let's actually get it out, because I think that's the hardest part about the graded assignment is getting these things out. So I'm going to have to do some iterators. So I'm going to show you some shortcuts. The first thing I would do, because my outside loop is an array list, I would go over to chapter 3. I'm going to click array list. I'm going to scroll somewhere in here. You could do this type of for loop. That would work. But I'm going to do this type of for loop. So I'm just going to say for each whatever in whatever. So I'm going to do this one. So I'm going to say for each. And then what's inside here? Well, it's a hash map of a string. And I said student infos. So I'm going to say student info singular of student infos. This is common practice. I know it gets a little confusing when you're not used to doing this, but this is usually the singular version of this one. It's very simple. That's common practice. Singular, plural. So if I just did this and I said student info, I want to show that as well. I will show that. That was a good question. Oh, of course. And if you have anything wrong in anything else, it does not like that. So you have to make sure that okay, so this is a good point to bring up. This is my student class. I'm not even running my student class. I know that I'm saying student stuff in here, but I did not bring in my student class in this. But even though that was where the error was, it wouldn't let me even compile this. That's the difference between JavaScript and Java. Java will not let you compile with errors, with certain type of compile errors. It just won't let you. So even if it's in a different class, sometimes you got to fix that error before you can even work on the class that you're trying to work on. That's because it's compiled. It does its magic, makes things more efficient so that it runs a little quicker. So here, if you see, it's printing out something weird. It says skill, age and name, and then an empty one. Did I do? Why didn't nobody catch that? Come on. Oh, you did? Sorry, wasn't paying attention. Okay, let's run this again and let's see what prints out here. Rerun it over here. Okay, so there's 2 things. It gets brought in. Now, so with these, I do want to bring up, do you see how I put the name in first and then the age, and then down here it's age and then name? Whenever I put in the name, age, and skill, it does skill, age, and name. How you put them in does not always represent how they come out in a hash map. A hash map just guarantees that the key and the value will always be paired together, but it does not guarantee in what order as a whole they'll come out. So just so you know that. Okay, so it does iterate over them. but I don't want to iterate over them as a whole. I want to iterate even over each thing individually. So I'm going to say, as a header, and then I need to iterate inside the hash map. There are two ways to do this. I like a different way, but because I'm showing you how to use your resources, if you go to the hash map thing over here and you go to this thing right here, this is how you can do it right here. So if I just copy this over, remember I got this from the book, hash map, array list, hash map, for loop. So I'm just going to go right here. And then I do need to bring in the map thing. Okay, so this says entry. Now remember, my entries are string. I can say student, sure. What I'm iterating over is student info entry set. And then what I'm going to do here is print out the key, the value, and again, with the example, they did like some kind of sum. I don't care about that. So I'm just gonna ignore that. And I'm gonna run this and see what happens. Well, it says here, student info, skill, age, name, student info. Let's add an extra line at the end of this. Let's do at the end. I'm just going to print an extra line. I'm not going to put anything in it. Let's rerun this. There, it breaks it up. So it has student info and it gives me my three things. My student info and does the three things. Let's say I don't want the parentheses around it. I can do whatever I want to. And now I just put a colon in between. Let's rerun this. There we go. So now I have these. I deleted that. She hurt her ankle and now can no longer hop on one foot. The other thing I wanted to show you on this, the reason why I deleted it in a technical aspect is to make sure that you know that hash maps do not have a defined length. And so whenever you use this for each of things, you're not saying do this iteration 3 times, because on the third time, if you did the Leah one on the third time, it would throw an error because there's not a third thing. So using these enhanced for loops when you do not know how big something is kind of powerful. Something else, random thing to throw out there. There's print, and then there's print ln. I just wanted to show you if I don't do the print ln here and rerun this, it does not do a new line at the end of this. So print ln is the same thing as doing this at the end. Have we done these escape characters before? /t, /n. So yeah, the /n, good. These are the same in JavaScript as in Java. The /n will do new line, so I can rerun this. And even though I'm not doing the ln, I'm doing the /n, it does it for me. Either way is acceptable. I just wanted to make sure you knew, because on your graded assignment, just throwing it out there, one of your prints should not be print line. One of them should be just print. It looks almost the same, but then you're like, well, I want it on a separate line, or I don't want it on a separate line, or whatever else. Just know that that's what's going on there. Good. I think that was it with this example. There was one other thing now that I looked up here that I did want to talk about, so I'm going to comment this out so it doesn't print each time. Somebody was asking about the string and the equals. So I told you I was going to show you a good example of this. I pulled this from somewhere. Remember, Java is compiled. So whenever I hit this run right there, it doesn't just say, oh, run line 1. No, it takes, in this case, it's running all of these packages right here. It's taking these five files. It's taking all 5 of the files. It's jumbling them all up, making sure that it knows what's going on, making sure that it knows the connections, and it's trying to compile it in a way that whenever it runs, it's going to run as fast and as efficient as possible. Because it wants to run fast and efficient, anytime you give it a string, it's going to put this hello, that's all capital, in that string constant pool. It's a pool, you know what a pool, like a, just like a pool. It puts it in the pool and it says, I am identifying hello, that anytime you access it after this, it's going to print to the same thing. So S1 and S2 actually print to the same exact memory location. It created this string object of hello, and because it said, oh, this is the same thing, why am I going to keep on making all these additional memory allocations? Why don't I just point it to the same thing? This mainly only works with strings, so yes, strings are slightly different. This one here, though, when I say don't just assign it to a string that might be in the pool already. When I say create a new string, this is explicitly saying don't put this one in the pool. So when you say S1 is equal to S2, because they're pointing to the same string in the pool, it'll say true. When you say S1 to S3, because this is a new string, it's not in the pool. It's creating its own instance, so it's going to say false here. And then when we do the dot equals, all of these, because the characters are the same, all the time when we do the dot equals, it'll say true. So I'm just going to run this to prove it to you. The only one doing false is the 1 to 3. That's because they're not the same memory allocation. But the dot equals is. Now, those of you that want to get super techie and super into the weeds, if I just hold control and hover over equals, this is an equals, but if you look, it's to a string object. So this is in my string class. This is exactly how it determines if it's equals. It says if an object that it brings in is equal to this, meaning the memory allocation is the same, return true. Look, that's the same structure we did. They also want to know, is it an instance of a string? That's kind of like that casting thing or the get class. And it also wants to know this Latin equals. If I click into that one, this actually grabs the value from both values, the value that you care about and the other one. And it goes bit by bit, character by character. It puts it into like an array. And it goes character by character. And if any of those are not equal to each other, it returns false. And that means that if all of them are the same characters, it'll return true. So it does show you the code in there if you really want to dig into it. I rarely do, but it is there for you if you want. Okay. I do want to just mention the studio. I have not done a lot of prep work for the studio. I meant to do a little bit more, but that is one reason why I did the that other thing. This array list and hash map. Hopefully you guys can figure out how to do that a little bit better now. Good question. With every language deals with strings differently. JavaScript 100% deals with it differently. Most languages that are considered object-oriented programming languages, like Java and C#, those will handle things the same way. So Java and C# developers can go back and forth pretty easily because the structures are the same. The libraries are different, So the exact string method they call, instead of saying toString, it might say print string, or I'm just making things up, but they might be worded different because the libraries have different methods in them, but their overall structure is the same. And then every other language after that, it just depends on how it's set up. So, JavaScript and Python are somewhat similar because you don't have to identify types. You can throw in whatever you want to. So it just depends on the language. Go has pointers, so you can use pointers. So it does depend on the language, but there are similarities. Other human language. No, whenever they created Java, remember Java is a global programming language. So, it can be used anywhere. I think whenever they were creating it, they probably went back to whatever. I don't even know. Don't worry about other languages, other human languages. I'm going to say something about should we be okay? So because we're talking about, I will talk about graded assignment real quick, just to review it. So assignments, console. So you're supposed to review the code. Hopefully you guys have already done that. That should be already in place. It kind of shows you how to definitely read through this. 100%. I just talked about hash maps and how to put things in hash maps, right? So hopefully that's there. Whenever you do your thing, these are hash maps. It's name and then the name, the employer. These are all hash maps. Task 1 is to mainly just print. When you do all of them, you should print. Select 1 and then 0. So I think that's what I told you last time. That's your main thing. And to be honest, from previous experience, this takes about half of the time. Not the majority, but about half. These other ones go pretty fast, only because if you just read the directions, look at the previous code that's already in there, between this and the previous code and just editing what's there, you should be able to do the majority of these things. You might run into a syntax issue and you might run into just a little bit of some other issue. That's when you reach out to your TA or ask a very generic question on Discord. But whenever my last course that I was helping out, most people were able to do a lot of this. It was the syntax stuff that they were able to run their program, but then when they ran their test, there was like, well, the test wants this look and you have this look and you added an extra space somewhere. So know that those will happen. It is very picky. I don't see attempting step 5. I'm trying to look for a step 5. Oh, this one. Test that it prints the descriptive messages if no jobs are found by selecting 0. And then 3 to search for that location. Okay, yes. Just do at the end. Okay, forgot. Yeah, I don't have my code up there, but yes, what you could do is just check to see if the jobs that come in, I forgot the variable, that's why I'm having a struggle, but like the filtered jobs or the jobs that are coming into the print method, you're just going to check the size or the length. You guys got to figure out which of those to use, but you're going to check the size of the length and see if it's 0 or see if it's empty. There's many ways that you can do that. But if no jobs come back, you do need to print something out to the screen. That one's a kind of easier one. I would just do that at the very beginning. The first thing you check, are there any jobs to even print out? So print something. Use the tests. So you're going to fail all the tests at the beginning. Just run the test and see what they should look like. Hopefully that answered that question. So remember, if you're struggling getting rid of a line after the search term, and yeah, make sure that you get rid of the LN. The LN does the next line. You might have to add somewhere in there a /n or a blank print line statement. I mean, hopefully you guys saw whenever I did mine, whenever I wanted to do a blank print line, I just did this right here. That'll print out just a blank line. So if you want to add a blank line, you do this. If you want to delete a line or something, a line afterwards, you get rid of the LN. So go back and forth, mess with those. I think if you wanted to add, yeah, I think that should be good enough. All right. Last thing is studio. So on this studio, in a perfect world, remember, we don't always live in a perfect world, so just try your best. But in a perfect world, what you want to do is you want to take what you designed last time and actually implement it so you can print out your menu. Okay? That's what you want. I think whenever I looked at the studio, I don't think I put any of this stuff in there. I think they already had a main menu and menu item for me. So what you might want to do is take your menu and menu item that you created, compare it with the ones that are in here already, and modify it. This is not the end all. Like, if you modify this, this is your project. Have fun with this, explore this. But one of the things that it does ask is that this is new is there. I think this is the minimum thing that it wants. So what you want to do, it wants you to I think it makes you within the restaurant package create a class called restaurant public static void main. Okay, if you want to, you can create your own, or this can be your restaurant class. If you wanted to do this and refactor this and rename this to restaurant, you can do that. It just needs a public static void main. That's where your restaurant is. So hopefully you don't think that you're missing something if you don't use the main, because they don't talk about main here at all. They said add this in, which they already had a main. So, and then use the main method. So right here in your main method, this is where you're going to and everybody knows the shortcut. If you hover over everything, control and then /, it does this thing. So this is where you can create your thing and then print the entire menu and then print an individual menu and, do your things here. So that's what I would do there. Again, with your menu and your menu item, they already have a lot of these. This actually sets all the items. I was talking to some people about adding items. So you could have a public void add items. And then what you're going to do is you're just going to actually type in one menu item. This is not in the directions. This is what I'm saying is you can do whatever you want to here, as long as you're meeting the minimum requirements. So I always like one of these whenever I'm dealing with array, rather than setting all of the items, I just want to add one item. And so I do items.add that one item that I did. However you want to do this, please have fun with it. If you have questions, let me know. But really, it's just trying to implement. And hopefully last week, your menu and your menu item were at least close enough to being actual classes that you can implement. And then this week is the actual implementation of it. So. Yes, so the restaurant, so the menu should have menu items on it. So that's what these are, menu items. And then you're right, there are a couple different ways you can print. Let's say that I wanted to imprint. Is everybody good with the shortcut here, the S out? If you just do S out and then hit tab, it saves so much time. So I can do menu, and then whenever you print whatever you want to here, remember this is going to go to the toString method. If you have not set up the toString method, it will not know what you want here. So one of the additional things this week should be, if it doesn't tell you, is to go ahead and set up a toString method. And I am fine with you doing this one at first and saying, okay, but then modifying this. Like items is going to be an array list. So there's a couple different things you can do. You can actually like iterate over the items right here. So instead of returning this, well, this is a return. You could do a print menu. I think that's what somebody else suggested too. Instead of trying to return a big, huge string, you could just make your own public print menu. I don't even know what I'm typing. This would be like a void, and then I would do a whole bunch of S out statements in here. You can do that if you want to, so that in your menu, in your restaurant, instead of doing the system out print line here, you would do print menu like this, and it's actually printing it from the menu, not from the restaurant. It does not matter which way you do it, just start printing, exploring, trying things, having fun. You will be doing the add several items. So all of your new item creations should be done in your main. So I do hope that that makes sense. You're actually creating everything in here. Yes. Okay, I'm gonna stop the recording.